Hello, this is the Math 121 class. I want to share my screen with you. We're finishing up week 2. During week 2, we started with the chapter 2, the set theory. We went over some material in the My Math Lab in reference to the set theory. I also provided you with notes on chapter 2 in class, and also attached the lateral part of chapter 2 in the Genza bar, the VU site. If you look under your class, if you go on the main page, click on handouts, it will take you to this screen here. If you click on set theory, it will take you to the notes that I have provided for you in reference to the Venn diagram. Okay, Venn diagram, it shows your similarities and differences between two or more items. You can apply it to your math or science project, probability, logistics. So basically, it's about knowing the concepts of a Venn diagram. If we look at this universal set here, this universal contains the set A, okay? And if you're not part of set A, but you're part of the universal set, then you're outside of A, but in the universal set. All right, and so you may see this in the My Math Lab, where it has an A or a variable with a line or dash beside it. We call that the complement of, and it's meaning that what are the elements not a part of the set. Okay, so just in case you see that. So I've provided notes for you. We have an example, sets A and B, the intersection of A and B, intersection, this is the intersection symbol. The intersection of A and B, we have to know what's in the universal set, what's in A and what's in B. It makes it easier to find the intersection, what they have in common. What do they have in common? They have a 7 and a 9 in common. The union of B is all of A and all of B. Okay, so that would be 1, 2, 3, 4, 5, 7, and 9. Now, A prime, well, the complement of A is everything that's not part of A. So if I look at and see what's part of A is 1, 3, 5, 7, and 9. So what's not part of A would be 2, 4, and 6. Okay? And then same thing with B, complement of B. What's not part of B? Well, I have to know what's part of B first. That's 2, 4, 7, and 9. So what's not part of B would be 1, 3, 5, and 6. So you have to make sure you include, part of the universal set. I've also given you links that might be helpful for you. Finding the cardinal number of the union. I gave you that formula. We'll get into the Venn diagram and completing the regions. All right, so use the Venn diagram below to show the number of elements in regions 1 through 4 to answer questions 1 through 8. So it says, how many elements belong to set A? Set A is the blue. So if you outline set A, it has 18 and 7, so that will be 25. Elements in B, go around the red, that's 12 and 7, that will be 19. How many elements belong to set A, but not set B? Okay, so we have elements in A, but not B, so I have to exclude the 7. Okay, And so look at A and don't count the number of elements that are part of B. Note that 7 elements are part of A and B. So there are 18 elements that are part of A and not B. So hope that makes sense. And how many elements belong to B but not A? So B has these 2, but 7 belongs to A. So 12 would be the number of elements that belong to B and not A. All right, so continue, and this is what you just use in your Venn diagram. And so now when we get into more complicated things, such as this one, the Venn diagram shows the number of elements in region 5. And so when you are working a problem, the place that you want to start is the intersection of all 3. Because once you can do that, then you can go to the other intersections. Okay? So you're given the number of elements in the universal set. So all of these 1 through 8 added together should be 44. You're given the number of elements in A, B, C. You're given the intersections, which is very good. So you want to start with the intersections. Okay. We're given that the intersection of all 3 is 3. So this is your starting point. And so I can start with any other intersection. If I want to do the intersection of A and B, which is 7, you have to know what is the intersection of A and B. A and B is this right here. A and B would be 2 and 5. And so together that should be 7. So that means 2 has to be what? 4. So you have to put that in. See that? And then I go to another intersection, which I do B and C. B and C, it should be 9. The intersection should be 9. And we have, the middle is 3. So that means that 3 plus 6 is 9. So that's the intersection of B and C. And then we can do the intersection of A and C. Let's see what the total elements for A and C is. It's 8. So therefore, what should be 4? What should be in region 4? If the total should be 8. So let's look. 5. Very good. See? And I break it step by step. So once we have all of the intersections, now it makes it easier to find this missing number, this missing number, this missing number. And once we have all of this, we can find this missing number. Okay? Because all of the elements in A should total 14. Let me go back up to the top so we can see. Yes. So the number of elements in A should be 14. So that means that you have to include 4, 3, and 5. So right now we have 12. And so that means that the missing elements 2, because the total is 14. You see, it's a matter of doing mathematics to add and subtracting. That's it. So hopefully, and then you go and find out this missing region, this missing region. And so once you have that, if you follow the notes, it's going to tell you, I'll tell you basically to add everything you're given, okay, that you have so far. You know that the total number should be 44. And so you have all the regions except for the number of elements in 8. So we can solve that just like a linear equation, pretty much. And you find out that that's 8. And so basically that's working with the Venn diagrams. Again, look at my notes so that you can follow what we just covered. Okay, hope this has helped. If not, let me know.